Okay, students, welcome once again. So we were doing we were doing the profit function and solve one or two exercise based on the profit function. Now, in continuation, let us take this example. If the total cost function of a firm is Cx is given by x cubed by 3 minus 5x square plus 30x plus 10, where C is the total cost and X is the output, and price are being determined under perfect competition, is given as 6, right? In the remaining two exercises, we have simply calculated the profit function. We didn't calculate the profit under either the perfect competition or monopoly. So I will try to explain these two cases also with the help of suitable examples. Find for what values of X the profit will be maximum, and then will the firm continue the production. So let me answer the second question first. Naturally, the firm will continue the production if the profit is maximum. Naturally, every firm wants to try to maximize the profit, and if the profit of a firm is maximum, then the production of the firm remains continued, right? So what is given here? We have given here the total cost function Cx, right? And what we want to show that determine the output X and the price under perfect competition is given as 6. Find for what value of X the profit will be maximum. Means you have to maximize your profit function under perfect competition, right? So naturally, first find out the profit function, and you know the profit function P is given by R minus C. R represents the total revenue function and C represents the total cost function. So total cost function is given to you. This is your total cost function. We have not given any revenue function, right? So what we will do here, if we have not given any revenue function, then we will use the concept of marginal analysis. In the last few lectures, if you go through, then you will find that the profit is maximum if the marginal cost is equals to the price itself, right? So we will use the second condition. Actually, the difference between this question and the question which we did earlier, till now, we were having a proper profit function, and profit function is being calculated with the difference of revenue minus cost function. And then what we did, we find out its first derivative as usual, equate it to 0. We get some stationary points, and then we will find out the second derivative dp over dx square and put this stationary point in this. If it is negative, then the profit is maximum at that stationary point. But here the problem is what? Only cost function is given. We don't have any data available in this question by using which we can also determine the revenue function. So we cannot use this concept now. So naturally, we will use another concept which is known as the marginal analysis. Profit is one of the important tools for any businessman. So a number of formulas are being developed to maximize the profit. See, this is your total cost function, right? C is given as x cubed by 3 plus 5x minus 5x square plus 30x plus 10. Now find out its first derivative, that is the marginal cost. So the marginal cost is given by, if C is this 1 upon 3x cubed minus 5x square plus 30x plus 10. This is your total cost function, right? Find out its derivative, that is dc over dx. It will represent your marginal cost. And this is what? 1 upon 3. Derivative of x cube is 3x square minus 5 will remain as it is. And derivative of x square is 2x, so 5 into 2, that is this, and derivative of 30x is 30. So what you will get, this will cancel out, x square minus 10x plus 30. This is its derivative, right? And this derivative simply denotes the marginal cost. Now calculate the second derivative also. The second derivative is what? Naturally, the derivative of x square is, the derivative of x square is, 2x, and the derivative of minus 10x is minus 10. So this is your second derivative. Now we will use the concept of marginal analysis, and in marginal analysis we have seen that the first order condition for profit maximization under perfect competition is what? The marginal cost must be equals to P, that is the price, right? And what is the marginal cost? So equate marginal cost is equals to P. Marginal cost is x square minus 10x plus 30. So x square minus 10x plus 30. This is our marginal cost we have just calculated. And price is given as rupees 6. So this is what you will get, the equation like this: x square minus 10x, 6 should be transferred here, plus 24. This is equals to 0. Now find out its factor. So naturally this is a quadratic equation. It will have two factors. What you will do, find out the two factors of 24 whose sum should come out to be minus 10. So that is 6, 4 and 6, right? So minus 4 minus 6, this is minus 10, and minus 4 into minus 6 you will get as 24. So naturally this can be written as, if you simplify it, x square minus 6x minus 4x plus 24, this is equals to 0. Take x common, what you will get here, x minus 6. Take minus 4 common, what you will get here, x minus 6. This is equals to 0. So x minus 4 and x minus 6, this is 0. So this implies x is 4 and 6. So these are the two values of x which we have already calculated, and this is the first order condition. They are known as stationary points by the concept of maxima and minima. Now for the second order condition for the maximization of the profit under perfect competition is, the second derivative should be greater or equals to 0. You can go through the few lectures earlier back. We have discussed these two conditions for maximization of the profit. Now second derivative, see what happens here. The second derivative is d square c over dx square is 2x minus 10. So see, d square c divided by dx square, this is equals to 2x minus 10, and your stationary points are what? 4 and 6. So see, the value of d square c at dx square at the point x is equals to 4, first point. This is what? 2 into 4 minus 10, that is 8 minus 10. This is equals to minus 2, and this is negative. See this. So the second derivative at a point x is equals to 4 is coming out to be negative, and at x is equals to 6 it is coming out to be positive. So what will happen at x is equals to 6, thus x is equals to 6, the output level where the profit is maximum, second derivative should be positive, right? This is positive. The condition here, this is a different condition, because the second derivative should be positive. So here the second derivative is coming out to be negative, and here the second derivative is coming out to be positive. So at x is equals to 6, the second derivative order condition is satisfied. So what does it mean? Thus x is equals to 6 is the output level where profit is maximum, right? Now we can calculate the maximum profit. So the maximum profit can be calculated by using this formula. See here, it is coming out to be minus 46, right? it is coming out to be minus 46. So how we will calculate the maximum profit? The maximum profit is being calculated by P is equals to, R minus C, and here P is, R is what? Px, C is given to you. What is P? P is 6. See, P is given 6 rupees and X has also come 6. So 6 minus cost functions, right? So this is 6 into 6 minus, this is the cost function. Put X is equals to 6 in this expression, you will get 46 as the profit. So naturally, if the profit is coming out to be negative, it shows that there is a loss of the firm of rupees 46, which is more than the fixed cost, that is rupees 10, right? Thus, the firm will discontinue the production when the price is rupees 6, right? Naturally, when the profit is coming out to be negative, therefore, the production should be stopped immediately. So, let us take this example also. It is also somehow similar to the earlier one. Let the market supply function of a commodity is S is equals to 80 plus 10P. We have taken any variable, we have taken here the variable as S, right? Where S denotes the quantity supplied in the market and P denotes the market price. In place of X, they have taken S. I have told you P is the price, X is the demand or supply. Any variable can be changed, right? So, where S denotes the quantity supplied and P denotes the market price, the unit cost of production is rupees 5. It is felt that the total profit should be rupees 800. What market price has to be fixed for an item so as to achieve this profit? What you want to do? You want to do what? You will have to determine the prices. So what prices of the commodities manufactured by the firm should be given so that the profit of the firm should become rupees 800. Here the situation is just reversed. We don't want to calculate the profit. Profit is already given here, right? So see, this is your supply function. S is equals to, see, your supply function is S is equals to 80 plus 10P, where P denotes the market price and the unit cost of production is rupees 5. So unit cost of production is rupees 5 means the cost of one item. Whatever items are being produced by the firm, the cost of one item is rupees 5. If it is felt that the profit is rupees 800, it is given to you that the profit is rupees 800. What market price has to be fixed for an item so as to achieve this profit? Yani what should be the price of the commodity so that the firm should achieve rupees 800 as a profit, right? So this is your supply function. Come to the solution. The supply function is given as 80 plus 10P, and the revenue function can be calculated as, the revenue R is equals to P into S. S means the quantity supplied. So P is what? P is what you will get here, 80P plus 10P raised to the power 2. This is your revenue function and this is your supply function, right? Now, how we will calculate the cost function? See, the cost function CXRC, it is equals to cost per unit. The price of an individual commodity multiplied by number of units supplied. So, what is this? The price of an individual unit is rupees 5 and the quantity supplied is equals to S. So 5S represents your total cost function. Now put the value of S. S is given as 5 means 80 plus 10p, right? Multiply this with 5, you will get the total cost function as 582 400 plus 50p, right? 400 plus 50p. This is your total cost function. 80p plus 10p square. This is your revenue function. And this is S80 plus 10p. This is your supply function, right? Now, what we have to calculate, the profit of the firm is given. We are interested to determine how much price for the commodity should be fixed so that the profit of the firm should be rupees 800, right? Now, to achieve the profit of rupees 800, we solve the profit function. Now, what is the profit function? You know, profit function is equals to revenue function minus CX. Revenue is what? Revenue is 80p plus 10p square. We have already calculated. So 80p plus 10p square, this is your revenue, minus 400 plus 50p, this is your cost. And this should be equals to 800, that is the profit, right? So what we are getting here? We are getting here 800. This profit should be equals to 80p plus 10p square. This is our revenue minus cost is 400 plus 50p. We will have to solve this equation to find out the value of p, right? Now solve it yourself. I think you can solve it. What you will get here, after some calculations or simplification, we are getting this as 10p square plus 30p minus 1200 is equals to 0. Multiply this by 10. So divide this equation by 10. You will get here as p square plus 3p minus 120. This is again a quadratic equation. Now see this quadratic equation. You all know at your earlier classes, a quadratic equation whose factors cannot be determined or which cannot be factorized, we can find out its solution by using quadratic formula. So this is what p square plus 3p minus 120, this is equals to 0. You cannot find out its factors. So what we will do, we will use the quadratic formula to determine its roots. So p will be what? The formula is minus b plus minus root b square minus 4ac divided by 2a. Now substitute all these values of a, b, c in the given formula. See here from this equation, what is the value of a? A is 1 because the coefficient of p square is 1. And what is b? B here is 3. B is equals to 3 because the coefficient of the middle term is 3. And here c is minus 120. The value of c is 120. Now substitute all these three values, what you will get. So p is what? P is 3. So we will get here minus 3 plus minus root b square means 9 minus 4. A is 1 and c is minus 120 divided by 2a. 2 into a is 1. Now you can simplify it. How you can simplify it? This is equals to minus 3 plus minus, you will get here root 9 plus 120 into 4. What you will get? 480 plus this is 9. You are getting this is equals to, see the calculation, this is coming out to be minus 3 plus minus root. We are getting this value 489 divided by 2, right? And the square root of 489, we can calculate the square root of 489 is approximately coming out to be 22.11, right? So what you will do next, so first take p is equals to minus 3 plus minus. First take minus value and then take the plus value. So after taking the minus and plus, the values of P are the value of first is minus 3 plus 22.11 divided by 2. This is value 1. Second value of P is minus 3 minus 22.11 divided by 2. Now when you will simplify these two, so you will get P is 12.5 and 9.55. And the price of any commodity can never be negative. Therefore, the negative value of the price should be ruled out, and finally the value of P is coming out to be 9.55. So if the price of a commodity are being fixed as rupees 9.55, then the profit of the firm would be rupees 800, right? So see, in all these questions, what we did actually, let us summarize our content of the session. See what we did in this session. We have learned how we can find out the maxima and minima of any function, and we know that the maxima and minima of any function can be calculated by using the concept of the first order derivative as well as the concept of the second order derivative. We have seen in the very beginning how we can calculate the maxima and minima of any function using the first order derivative. And then we can proceed the concept of maxima and minima to find out the maxima and minima using the concept of second derivative. And we know we can calculate the maxima and minima of any function. The process runs as follows. Let me summarize it again before finishing the session. You have given a function y is equals to fx. Find out its derivative, that is first derivative, dy over dx. Now equate this derivative equals to 0. And naturally, when you will equate this derivative equals to 0, it will be treated as an equation. And if this is an equation, naturally, you will have to solve it. And when you will solve this equation, you will get some values or some factors or roots of this equation. So these values of the equation or roots of the equation will be known as stationary points. And you know, or you must remember, these stationary points will give you either a point of maxima or a point of minimum, right? Because if you are getting the stationary points for any function, these stationary points will give you the point of maxima as well as point of minima. Now, among all those stationary points, which points will give you the point of maxima and point of minima, that we can decide it by putting the any stationary value of the given equation into the second derivative. Are you getting the point? Put any stationary value in the second derivative of the given equation. If second derivative becomes negative, means less than or equals to 0, then that stationary point will be considered as a point of maximum. And on the other hand, if the second derivative becomes positive, that is greater or equals to 0, then that stationary point will be considered as point of minimum, right? And once you have calculated the point of maxima and point of minima, then we can also find out the maximum and minimum value. Put the point for which you are getting the maxima, put that value of x in your original function, you will get its maximum value. And likewise, put that value of x for which the second derivative is coming out to be positive in your original function, you will get its minimum value. So after having the basic idea of finding out the maxima and minima of any function, we have extended the same concept of maxima and minima to three basic functions which are very frequently used in the area of business or commerce or management even, right? And these functions, are cost function, the revenue function, and finally, the last is the profit function, right? And the analysis of all these three functions using the concept of derivatives is known as the marginal analysis, right? That is why we are using the term marginal analysis. And how we can analyze these three basic functions which are very frequently used in the area of business and other activities. So what happens? The cost, revenue and profit, and you all know that the tendency or the basic tendency of all these three functions is what? The cost function is always minimized. Profit and the revenue functions are always maximized, right? So first we have taken the cost function. So cost function means whenever a function is given to you and it is a cost function, then it is understood that you have to minimize it. To treat the total cost function as a general function as we did in case of maxima and minima, and then use the same approach to minimize the total cost function. And likewise, the second case we are considering as the revenue function, and you know that revenue is always being maximized. So whenever you have given a function as a revenue function, maximize it as usual as you maximize a general function using the concept of maxima and minima. And the third case, if the revenue function is there and the cost function is there, if you take the difference of these two for any form, that is known as the profit function. And the profit function should also maximized, and for maximization of any profit function, we should use the same approach as we use to find out the maxima and minima of a general function. So what I want to conclude, that is, don't take these cost function, revenue function and profit function as a special functions. They are the functions which are very frequently used in the area of business activity, but they will be minimized or maximized on the similar principles of the maxima and minima as a general function is being maximized. So I think this is more than sufficient for you students. Thank you very much. I should stop the lecture here and continue in the next lecture in the subsequent text. Thank you very much.